Good morning, everyone. My name is Timothy Lee Grant, and today I am going to be talking about linked lists. So this is actually the third part in a series that I'm making on linked lists. The first video, I just discussed the general idea of what a linked list is, why you might want to use one, and I made an analogy to a subway station. So in a subway station, you have individual stations which are all connected through a train. And it's very similar to a linked list where you have an entrance and you can go down and access each of those stations, but you can't kind of skip over, and they're all connected in a very logical way, just like a linked list. And now in the second video, I started talking about, well, okay, how do you actually build this linked list where you have head pointing to the first element, and then you have each of these elements, nodes or stations, connected to each other in this chain and ending in a null pointer right here. So a little bit of notation, right? I have the actual structure right here. So it's a struct node and it has three elements. The first one is int data, second one is string name, and the third one is struct node pointer next. Now I decided to represent pointers as a triangle, okay? So triangle, triangle, triangle. And you'll notice here's that next element. It is a struct node pointer, which means that it points to or stores the address of what? A struct node. So struct node pointer next stores the address. So it points to, what is this? It is a node. Okay? And then head is always pointing to the first element in your linked list. So that was the second video. So in this video, I want to go over how do you actually start manipulating data within the linked list. So for example, what if you want to delete a node? How do you do that? Okay, well in this video, I'm going to start discussing how you insert and delete nodes from linked lists. All right, cool. Let's say you want to delete this link right here, the UCLA, okay? So with linked lists, you can't just jump to the middle of a linked list, right? I said in the first video that you need to kind of like ride the train. You have to enter into the subway at the entrance, and you have to go from station to station to station, and you can't really just jump to the middle of the station, right? Well, same thing in a linked list. A linked list works by you accessing the first element within the linked list. This is kind of like your entrance, is head. This is how you get into the subway station. Then from this, you have to ride it, and each time you get to another station, you have to check. Okay, well, is this what I'm looking for? No? Okay, well, then I'm going to go to the next one. Is this what I'm looking for? Hey, it is. Now you can kind of do something with it, right? So we use this current right here as kind of our passenger, right? So he's going to get on to the first element, go down to the second element, go down to the third element, and when he's at the third station, he's going to say, here we go, I found it, I got it, okay. Now I can do something with it, but let's start thinking ahead a little bit. So current eventually, and I'll show you how it's going to do it, is going to point to UCLA. But we're trying to actually like delete this, right? We want to delete this. So we need some way, ultimately, I'm just showing what it will look like. We want this next element to point like that, right? But remember what I just said about not being able to jump to the random element within a linked list. You have to kind of write it. How can I access this element? If current, the passenger, is at this station, I can't really go back a station. Does that make sense? I can only go forward. So we actually need another pointer. We need a pointer that's going to be pointing to this last one, okay? So I'm gonna create another pointer, and then I'm gonna show you how to actually go about doing this. So I'm gonna erase this because we haven't done that yet, okay? So right now, this is what it is. Current is pointing to nothing, and head points to the first element, and we have this full link, or full linked list. Okay, so let's create that extra pointer that we need. So, struct node pointer, and then previous. Okay? So here we go, struct node, and this is previous. Okay, well actually, hold on. Let's just make this one previous and this one current, just so that we don't have lines kind of mixing up, right? They're both struct node pointers. Okay, cool. So we created this. Now, what do we need to do? We need to kind of ride that train, right? So I'm going to set current. I need to get on to the first station, the entrance of the subway station. So I'm going to set current equal to what? Head. Because I can't access this. I don't have access to the subway station except through head. I have to go through head. So head is a struct node pointer which stores the memory address which the first element of the list is. Current is also a struct node pointer, so they can accept the same type of data. Current equals head. All right, so what does this do? This means that current is going to point to the same location which head points to. Head is pointing there. Okay, cool. So now I can do a loop, and I can keep writing this until I hit the end, or until I hit the data that I want. So let's just do it manually, and then we can add the loop later, right? So if we have this, there really isn't any previous, right? So let's just go to previous equals current. Okay, so now previous is going to be to the same location. So right now, all three of them point to the first one. Cool. Okay, so we got this. Now, what do we want to do? We want to take that train, right? So remember what I said about that arrow operator. The arrow operator means go to. Dereference is what it's called, but whenever you dereference, that just means that you go to the place where you're pointing. So current and then what do we want to access? Next, right? So current, and what do we want to access? We want to access this next. So we go to current, and then access this next variable. And this next variable points to MIT. And what do we want that to be? Well, we're trying to travel it, so we want current to be that, right? So what we can do is, I don't think you guys can see that. You can do current equals current next. Okay, so what's going to happen here? So current is going to be right here, and we're going to change this current value. And what are we changing it to? We're changing it to, okay, well, where current is, go to where current is, access the next element, and set that equal to current. So next is pointing here, and that's what we're setting current equal to. Like this. So now they point like that. All right, well, this is kind of what we like, right? We have previous, which is up to the first, or the element before current, and current is kind of right in that train. All right, so now we can just go and ride the train again. So how are we going to do that? Well, very simple. We just do the exact same thing which we just did. So we want to change current. So current equals current next. And now prev equals prev next. Okay, so what's that going to do? All that does is change current was pointing here, and we go to current and go to access the next element, and that's pointing to UCLA, so we say that that's what current is going to be. Then previous, we do the same thing. So this is how you just ride the subway. I talked about that extensively in the first video. All right, so now we have this set up, and we can do, how you're going to test it is current, all right, it would be a string compare. String compare, and what do you want to compare? So you want to go to the element which is stored at current. So current. So you go there and access what variable? Name. Okay? And then you can say if that's equal to UCLA. UCLA, like that. Okay? So this is how you test if your current, if your passenger is at the station which contains the data UCLA. So current is here. Go to it, that's what this arrow means, go to it and then access the member variable name and compare it to see if it's equal to UCLA. If it is, that's what we want to delete. Okay, so this is going to return true, so we know that we want to delete this. All right, so how do we actually do that? How do we get rid of this? So there are a few things that we want to keep in mind. First thing is we dynamically allocated this node, which means we need to manually delete it. We can't just we can't just connect here to here and call it a day, because this UCLA memory is still allocated and we need to free it, okay? So what we need to do is we need to connect this next variable of the MIT over to NYU. Does that make sense? So what's going to happen, we need ... because this hasn't happened yet. We need like this. And so what's going to happen? You access head, it's the first subway station. You come down to MIT. Then from MIT, you go down to NYU. Well, that looks like we want. And now notice, this current, it's still at UCLA, so we can still access it. Remember how I said you need to be able to have a pointer to a link or a node if you want to access it. You can't just jump in the middle. Well, we have the link right here, so let's kind of change this. So how do we accomplish this goal right here? Well, previous is pointing to MIT, so what we can do is prev. Now, so go to previous and access which member variable? The next. And we want to set this equal to what? To this one. Well, how do we do that? That's current next, right? Current next points to there, equals current next. Okay, so that takes this away. It's no longer equal to UCLA, but rather it's equal to NYU. Okay, cool. That's almost what we want. Now we just need to delete this. That's simple enough. You can just use the free, and then current. Okay, and then what's that going to do? It's going to go here and delete this memory. Say goodbye, 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 goodbye. There we go. Just deletes this memory. Okay, that's exactly what we wanted. Look. Cool. Okay. So now what else can we do? Well, what if we want to just insert an element? Let's say we want to insert UCLA right there. All right, so how are we going to do it? Well, as I said, we need to get on the subway station. That's previous. Okay, so we're going to get on the subway station. So current equals head and previous equals head. All right, so we're on the station. Not there, but right there. Okay, we're on the station. Okay, cool. So we want to travel down. So current travels, current equals current next. Okay, current equals current next. Okay, very good. Now travel once more. So equals current next. So current equals current next. Like that. And now previous equals MIT. Equals prev next. Okay, so previous comes down to be MIT now. Okay, so now we kind of have things set up. We have the access to the element above and below where we need. Okay, cool. So let's actually do the lines of code which allocate memory. So how did I say we allocate memory? We use that malloc function. Okay, so let's get rid of these. And where do we want to allocate that memory? Well, we want to have this element's next be at the memory location. So where is that? That's previous next. So I don't know if you guys can see that. Prev next equals what? So we need to cast it as a struct node pointer, and we're going to use the malloc function size of struct node. Okay, so it's a long statement. Previous next, and we're changing this is equal to something. Okay, well it's equal to, and we just allocated memory, so it's an amorphous blob memory, and we're changing that. Okay, so it points to this random thing that we just created, amorphous blob of memory, that has the size of a struct, so it has the memory, the amount of memory which a struct has, and then we cast it as a struct node, so now it's no longer an amorphous blob, but rather it is a actual node with a next and a name, but we didn't actually create the name. And right now the next kind of points to garbage. Okay, so that's looking better. We got that, okay. So now, once we allocate memory, we have this pointing there, and great. Let's, we need to connect this next to this element. Well, look at that. Look at, we have current pointing to that element. That seems pretty easy. So why don't we just change previous, and we can go to there. We can just travel down. Previous equals previous next. All right, simple enough. And I'm gonna just connect that like there. And so now previous is right there. Okay, very good. So now we want to access this next variable. So prev access the next variable equals what? No, it's just current, right? Current. That's very good. Now this is no longer pointing to a random location. It's pointing right there. But hey, that's exactly what we wanted. Now we just need to fill in the name. Let's do it. Previous equals, previous, and we want to access the name equals UCLA. Now in actual C or C++, you are going to have to use, I think, the string copy function, but I'm just writing this just for like simplicity's sake. So, all right, this goes to previous, go to previous, access the name element, name, and change that to UCLA. Well, there we go. We did it. We did it. Look, this is exactly what we want. So that's how you delete an element in the end or in the middle of a linked list. Okay, well, maybe you want to ask, well, how do you add an element at the beginning of a linked list? Okay, well, let's do that. Let's add an element to the beginning. That ought to be fun. Well, what would we like? We want kind of like this. We want a thing here, which has next, and this next to point there, and we want head to point to it like that. That's what we want. That's our ultimate goal. Okay, so what we can do is we can do, let's set up current to be equal to this element right here. Okay, so we can get on the station equals head, and then current equals current next. Okay, so current here. I don't know why I did that actually. That doesn't make any sense. So current equals current head, points it there. Okay. see, what else will we want to do? Well, we want this head to point to here. Oh, and why did I have this current here? Because I don't want to lose this first element, right? If I just change head to be equal to this doesn't actually point to anything yet, and so I would completely lose the linked list. All right, so I put this current here as a way to continue to access it. So now what we can do is we can do head equals, and then casting malloc size of struct. Okay? So now head no longer points here, but it points here. And we created this, but this does not point there yet. So I'm going to get it like that. This kind of points like that. All right. So now all I'm going to do is I can get this, and I want it to point to there. Well, that's easy enough. Current is pointing there. So head, and what do I want to access? I want to access the next member variable. Next equals what? Current. Okay. That changes this to be right there. So it points to the first element. That's good. Now I want to put a name right there. So head, access the name element equals, and what's a school? Davis, for UC Davis. There we go. Now head points to the first element, which is now Davis. Davis points to Oregon State University. Oregon State University points to Massachusetts Institute of Technology. MIT points to UCLA. UCLA points to NYU. NYU points to UCSC. And UCSC points to null. So we know that that's the end. Okay. I think you guys are starting to see the methodology of actually how you go about doing this. And I want to give a suggestion. Actually draw it out, because when I was first learning how to do linked list, it was very difficult for me to remember, okay, well, which pointer is pointing where, and which do I change the current first or the previous? How do I rearrange these? But if you actually draw it out kind of like this, it just becomes so obviously clear. And I think that people are a little bit concerned about drawing it out because maybe they feel like, it's not very, I don't know. I think a lot of people watch those videos where there are these guys who have been coding since they were, 3 years old or something like that. And then just bam, 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 bam. And then they try to kind of emulate them, and they don't feel good if they're not going at their level and their style. But here's the thing. Me? I mean, that's great that they're doing that, right? That's great that they're able to do that. But for me, I haven't been coding since I was 2, right? So I need this. This is how I learned, okay? And then through just practice, you get better and better. So just actually write this stuff out, and it becomes very clear what you want to do. And then you can just put it into a loop of, okay, well, start here and then keep looping, keep traveling through the train until you get to what you want. It's very easy. Let's, I guess we can do one more. We can go and let's add a element to the end. Okay, so what do we want? We want current to point to the first element because we need to get onto the train. Okay, so current current equals head. There we go. So current, head, and then do we need a previous in this case? So let me think about this, right? So let's see. So we have, I said we wanted to add, right? So don't think we do. Okay, so current equals current next, and then current equals current next. Okay, so then that just goes down the train. Now it hits here. And then we're going to keep doing that, bam, 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 until we hit null. Now, how do we test for null? Well, that's pretty easy. So if, and then current next equals null. So what's this going to do? It's going to go to current and access the next. And it's going to say, is this equal to null? Nope, it's equal to MIT. So it doesn't trigger. And then we're going to ride the train again and do the same test. And it's going to say, nope, it's not equal to null, it's equal to UCLA. Then it's going to ride the train again, go to UCLA, check the next, come here. Then once current, okay, so once current is equal to UCSC, what's going to happen is it's going to come here, it's going to go to current, and access the next and say, oh, yep, it's equal to null, right there, it's equal to null. So then we can do, inside this if statement, we can say, what? Well, we want this element to, and I actually don't think that you guys can see that, so current is pointing to this, and we want to create another link and have this element pointing there, right? Okay, well, let's set that up. So how do we allocate memory? Well, we access current next, so current next equals cast, malloc, and then size of operator. So we dynamically allocate memory, and then we set this equal to there. So now it's pointing here. What do we want it to be? We want this one was, you'll have to use like string copy, right? So we can travel the train once more. So current equals, and we just set current next to be equal to this new node, right? And this is what I mean by always make sure that you do these pictures, because I would have been confused when I was first learning to do it. Well, I just created this. Is the node actually there, and is next pointing to it? If you draw it out, it's clear. Yes, next is pointing to it. I just assigned current next equal to this, and it's pointing there. So it's obvious what my next move needs to be, and that's what I mean. When you actually start drawing it out, you see that your next move is obvious because you can see what is pointing where. And if you're just doing it in your lines of code, you're like, what's going on? So this way is much more effective. So current equals, what do I want? I want current to be pointing here. So current equals, and then current next. Okay, so that changes this to be that. Now I want to change the name. So current, go to current, access the name element, and set it equal to, what's another school? Harvard. Set it equal to Harvard, okay? Okay, well, we also have this variable, which is next. Well, what do we want to set it to? Now, it's the last link, so we want to set it to null. How do you do that? Current next equals null. Current next equals, that looks like it's pointing there, equals null. Okay? And then we can just get that so we can see this linked list. So head is still pointing to Davis. We can go down the chain, down the chain, down the chain, just like that. Okay? So this is how you can access elements within your linked list data set, and how you can remove elements, and how you can manipulate them. So I hope that this video made it more clear. I really like this visual way of looking at it. I think it's much more clear, and it's helps you realize what you actually need to do. So I would highly, highly, highly encourage you, just draw it out. No one is going to be like wondering why you're drawing it out. I mean, if they see you doing it, they're probably going to be like, oh, that's actually a smart idea, I'm going to do it, right? Like, you know what's better than being fast? Being right. You know what I mean? So draw this, and it's almost difficult to be wrong, because you see exactly what's pointing where and how you need to set things up. And then if you do get something wrong, well, then just keep going back and get it back to the original state, and then think about it logically. Like, okay, well, I'm erasing this and doing that. What is the line of code which corresponds to that? It's this. Okay, so I'm going to put that into my code. Then what do I need? I need this to point here. I'm going to rearrange it to that. And then you notice, oh, wait, no, I needed a previous to point to the other one. Okay, well, let me go back and then set things up the way that I need it, right? So that's how I would suggest it. Just start drawing it out and use a lot of the methods which I talked about, like traveling the train, allocating memory, and stuff like that, and you will be wonderful. So anyways, thank you guys so much for watching this video. If you would, please subscribe and give me a like. That would be great. And I hope that you guys have a wonderful day, and I will see you guys later.